Welcome to MAEnow. I am MAEcy. Join me while I check out research being done by Professor Avedisian's graduate student.
My name is Yuhao. Thank you for having me and welcome to my lab.
Why did you decide to attend Cornell and join mechanical engineering?
I decided to attend Cornell mainly because of its excellence in academics. There are a lot of exciting projects going on in mechanical engineering. For example, I have the opportunity to work on drop tower experiments using this package and the International Space Station experiments. It is a fundamental study and beneficial to the energy systems in our society, since it provides a complete picture of how a liquid fuel burns and help to reduce the consumption of petroleum-based fuels. I think all resources available here can facilitate my exposure on the frontier of knowledge and help me to develop into an independent researcher.
Please share with us about your research.
My research is about droplet combustion experiments and the microgravity environment. This is the simplest possible configuration for burning a liquid fuel. We conduct experiments in both ground-based drop tower and the International Space Station to obtain the microgravity environment. In this way, a droplet will burn in a condition that promotes a spherical symmetric gas transport, so that we could obtain spherical flames during the experiments. This kind of combustion symmetry is currently the only one that can be modeled using detailed numerical method of first principles approach for burning a liquid fuel. The drop tower facility at Cornell is 7.6 meters high, and it can provide an experimental time of 1.2 seconds with a low gravity environment, which is created by releasing the instrumentation package into free fall. Inside this package, fuel droplets are anchored by two small silicon carbide fibers and are contained in a sealed chamber of room temperature air. The droplet size is fixed at about 0.5 millimeter. Once the droplet of desired size is anchored onto small fibers, the package is released into free fall by turning off the electromagnet that fixes the package. The droplet is then ignited by two high-energy sparks. The burning process of the droplet is recorded by a color camera, which records the flame images, and a black and white camera that highlights the droplet and the soot boundaries. This video shows the results for algae-derived renewable diesel. We are trying to compare the burning characteristics of this biofuel with real number 2 diesel fuel. In this way, we can evaluate the potential of biofuels as additives to real transportation fuels. Therefore, we can work towards to reduce the consumption of petroleum-based fuels. We also have experiments on International Space Station as part of NASA's Flame Extinguish project. On International Space Station, we conduct droplet combustion experiments over a wide range of droplet diameters, and the diameter can up to about 6 millimeters. In this apparatus, we have two hot wires to ignite the droplet, and we can see a spherical flame after ignition. This fuel droplet consists of 25 decane and 75 propylbenzene. They are surrogate fuels for jet fuels. With large droplets, the radiation to the ambient starts to play an important role so that we can see flame extinguishment at some point. After the visible flame extinguished, the combustion enters to a region called low temperature combustion. That is, the droplet is still burning even though we cannot see a visible flame. In this zone, the droplet only burns at about 600 to 800 degrees K, and less soot will be produced, since the formation of soot precursors requires higher temperature. Engine manufacturers have been studying ways to reduce pollution that involves the use of low temperature combustion chemistry, but that chemistry is less understood. By studying low temperature combustion we found on International Space Station experiments, we may be able to obtain better understanding of cool flame chemistry, which could be helpful for engine manufacturers for the designs.
What would you enjoy doing after you graduate?
After graduation, I would like to stay in academia and to be a professor. In this way, I can continue to work on various thermal and energy-related projects. I can also work closely with undergrad students so that I can introduce research experience to them.
What do you do for fun outside of academics?
I really enjoy reading, watching movies, and jogging, just to have a balance in my life after my lab work.
Wow. I like to learn new things, and that my friend was exciting. Thank you for being part of MAEnow.
I really enjoy sharing my research. Thank you for having me, MAEcy.